from Sputnik to SpaceX. Space travel has come a long way since the first satellite, Sputnik, was launched into orbit in 1957. Today, we have the technology to send humans to space, and even to other planets, using a variety of spacecrafts and launch vehicles. One of the key technologies used in space travel is rocket propulsion. Rockets are used to launch spacecrafts out of the Earth's atmosphere and into orbit. Rocket propulsion is essential when it comes to space missions. The Earth's gravity is a very strong force that must be overcome in order for a spacecraft to reach space. The amount of thrust required to overcome this force is enormous and can only be generated by powerful rockets. Rockets work by expelling hot gases out of a nozzle at high speeds. This reaction creates a force in the opposite direction known as thrust, which propels the rocket forward. The more thrust a rocket generates, the more force it can overcome, and the higher it can go. Rockets use a combination of liquid and solid fuels to generate this thrust, which are stored in tanks inside the rocket. Rockets are also used to provide propulsion for interplanetary missions. Once a spacecraft reaches orbit around Earth, it needs to be able to travel to other planets. This is done by using a rocket motor to accelerate the spacecraft out of orbit and onto its interplanetary trajectory. Moreover, rockets are also used to adjust the spacecraft's orbit, to rendezvous with other spacecraft, and to perform maneuvers such as docking and landing. This makes rocket propulsion a vital technology when it comes to space travel, as it allows spacecraft to reach the desired destination, perform maneuvers, and complete the mission objectives. The most powerful rockets currently in use are the SpaceX Falcon Heavy and the NASA Space Launch System. Both of these rockets use a combination of liquid and solid fuels to generate the enormous amount of thrust needed to escape the Earth's gravity. Without rocket propulsion, space travel would not be possible. Another important technology for space travel is the spacecraft itself. The most well-known spacecrafts are NASA's Space Shuttle and the International Space Station, ISS. The Space Shuttle was retired in 2011, but the ISS is still in operation and serves as a research laboratory for scientists from around the world. The SpaceX Crew Dragon, Boeing Starliner and Russia's Soyuz spacecrafts are the current spacecrafts that are used for crewed missions to the International Space Station. In recent years, private companies like SpaceX and Blue Origin have developed reusable spacecrafts, such as the Dragon and the New Shepard, which are capable of landing back on Earth after a mission, allowing them to be used again in the future. This is a significant development as it reduces the cost of space travel and allows for more frequent missions. One disadvantage is that reusable spacecrafts are more complex than traditional single-use spacecrafts. They have additional systems and components that need to be designed, built, and maintained, which can increase the overall cost of the spacecraft. Another disadvantage is that reusable spacecrafts need to be able to survive the harsh conditions of re-entry and landing. This requires the use of heat-resistant materials and special landing systems, which can add weight to the spacecraft, reducing its payload capacity. Reusable spacecrafts also have a higher risk of failure during re-entry or landing compared to single-use spacecrafts, which could result in the loss of the spacecraft and its payload. Additionally, reusable spacecrafts require more maintenance and inspections between flights than single-use spacecrafts. This can add to the cost of the spacecraft and may reduce the number of flights it can undertake in a given period of time. Lastly, the process of refurbishing, refueling and preparing the reusable spacecrafts between flights can be time-consuming and requires a lot of resources, which can make it difficult to schedule frequent missions. Navigation and guidance systems are also critical for space travel. These systems use a variety of sensors, such as gyroscopes and accelerometers, to determine the spacecraft's position and velocity. They also use star trackers and other sensors to determine the spacecraft's orientation in space. This information is used to control the spacecraft's trajectory and make course adjustments as needed. Communication technology is also an essential component of space travel. Spacecrafts need to be able to communicate with mission control on Earth and with other spacecrafts in orbit. This is done using a variety of frequencies and technologies, including radio waves and lasers. Frequencies are used to transmit and receive information between the spacecraft and mission control. Different frequencies are used for different types of communication, such as sending telemetry data, commanding the spacecraft, and relaying video and audio. Radio waves are used for long-range communication between the spacecraft and Earth. Radio waves are able to travel through the vacuum of space and can be used to send information over large distances. This is how mission control receives data from the spacecraft and sends commands to it. Lasers can also be used for communication between spacecrafts in orbit. Laser communication systems use beams of light to transmit data at much higher speeds than radio waves. This can be especially useful when sending large amounts of data, such as images and videos, between spacecrafts. All three of these technologies play a critical role in the success of a space mission by allowing the spacecraft to communicate with mission control and other spacecrafts. This enables real-time monitoring of the spacecraft's status, precise navigation, and control of the spacecraft's trajectory, as well as sending and receiving data and instructions, which is essential for a successful space mission. Finally, life support systems are necessary to keep the astronauts alive while they're in space. These systems provide the astronauts with air to breathe, water to drink, and the ability to control the temperature and humidity inside the spacecraft. Space agencies like NASA have a rigorous testing and quality assurance process in place for life support systems, which includes testing in ground-based simulations, vacuum chambers, and other facilities that replicate the conditions of space. The systems are also designed with multiple redundancies, which means that if one component fails, another can take over. That being said, no system is 100% fail-proof, and even with the most stringent testing and quality control, failures can occur. However, the percentage of life support systems failing while in space is relatively low, and the risk is mitigated by the use of multiple redundant systems, and the ability to troubleshoot, repair and replace system components if needed. In conclusion, space travel is a challenging endeavor that requires a wide range of advanced technologies. From powerful rockets that propel spacecraft into orbit, to reusable spacecrafts, navigation and guidance systems, communication technologies, and life support systems, each technology plays a critical role in the success of a space mission. Thanks for watching.